Bonjour, Kinamagi and Ireland edition cast, and welcome to this production of the My Math Network. Today's episode, Chapter 6, Lesson 4, Hands-on using models to multiply decimals. All right, welcome to today's lesson. You will need your packets available to you for Chapter 6, Lesson 4. That begins on page 397. If you don't have that material, you should pause this video, go get the material, and then come back and unpause the video. If you need to go get your material, you may do so now. And welcome back to those of you who had to pause the video, and thank you for staying along for those who didn't. Our essential question of Chapter 6 is, how is multiplying and dividing decimals similar to multiplying and dividing whole numbers? And if you've been paying attention, the cheat to that answer is we multiply and divide using the exact same algorithm. Now the difference is in the location of decimal points. We're going to start out right in the book. And this will be on 397. As always, the expectation is for you to fill this in as we go. If you need to slow this down by pausing the video occasionally in order to finish writing something in before we move on, please do such, and I will put in periodic reminders to do that. The best thing you can do is to write on these pages, even though you may not be turning them in. And then at the very conclusion, you can just take your answers and put them in the Google form. That way the answers get to me quicker and I can get your feedback as well. So our first problem on 397 is find 3/10 times 7/10 using a decimal model. And I'm going to go ahead and I'm going to get my annotation tool. And the first thing we have to do is we're going to go 3 high, because 3/10, each one of these rows going across represents 1/10. So there's 1/10, 2/10, 3/10. And if we kept going 4, 5, 6, 7, 8, 9 tenths, and then if you get to all the way to the top and you fill it in, it's a whole. So it becomes 10/10 is equal to 1. So I'm going to go up 3. And then it's going to tell you how far to go over. And 7/10 means 7 columns up. So I'm going to go 1, 2, 3, 4, 5, 6, 7. From there, I'm going to make a rectangle. And I've filled that in. So it's 3 high, 7 wide. If you remember the formula for finding the area of a rectangle, it's length times width. So there are going to be 21 squares filled in. 7 times 3 is 21. And when we write that as a decimal, we'll start with a 0 for here. And the 21 hundredths means 2 in the tenths place and 1 in the hundredths. So you would write that out like this. Make sure you filled this in, including the sketching. I know the habit will be to want to just do the math to go 7 times 3 and then move the decimal place 2 spots. But for today, it's a good idea when available to sketch this out so that you can see that this literally means I want 3/10 of the 7/10. Or if this was all 7/10, it had gone all the way to the top, but we only wanted 3/10 of that. So you start visualizing that it's a fraction of a fraction. If you need more time to fill this in, feel free to do such by pausing the video. Otherwise, I'm going to clear the drawings and move on. And you can see the answer as well. All right, so let's talk about this. How are the equations 3 times 7 equals 21 and 3/10 times 7/10 equals 2100 similar? Well, how are they the same? 3 times 7 is 21. The math remains the same. How are they different? There's a decimal place. This doesn't represent 3 wholes, it represents 3/10. This doesn't represent 7 wholes, it represents 7/10. And 3/10 of 7/10 is 21 hundredths. You multiply 3 times 7, there are 2 decimal spots, so you come over 1 and 2, 0.21. And they have the same non-zero digits, different placement of decimal points. How is using a model to multiply 3 tenths by 7 tenths similar to finding the area of a rectangle? And if you think back to what I had said just moments ago, we were talking about the formula for a rectangle. You're multiplying the base, which is the bottom number. In this case, it was the 7 tenths, times the height, which was 3 tenths. So if you remember that going forward, that will be beneficial when we get into geometry. And I'm sure I'll reference it a few more times. And you can see that their answer was the product is the area of a rectangle with length 7 tenths of a unit and width 3 tenths of a unit. All right, so let's try one here. This is on the top now of 398. I'm going to get my annotation tool ready. We're going to go 4 tenths times 2 whole and 4 tenths. So it's going to be 4 tenths high, which means 4 blocks high. But now it's going to go, here's all the way to the end of 1. Here's all the way to the end of 2. And now I need 4 more counts. 1, 2, 3, and 4. I'm going to go up here. Let's see now that I got to color it in here. Get my text. All right, so now we know it's 4 high. So this is my height. My base is 2.4. So now I just have to find the area of that rectangle. It is 0.4 units wide and 2.4 long. So write that in. We shaded that in. And how many hundredths? Well, there's 40, 80, and 16. So it would be 96. And I can draw that here. Here's the first 4. Oops. Try to stay within the lines. Do better art than I just did there. Here's the next 4. And then there was 4 times 4 is 16. So I'm going to go, here's 10. And then 11, 12, 13, 14. So now you can see that if you put all of this into here, there are 96 hundredths in the shaded region. And that's written by 0.96. So our answer is 0.96. And I'm going to fix that error right there. I should write that as 0.96 hundredths. I should just actually write that as a 96. 96 hundredths is written as the decimal. There's 0.96. If I would have gone over 1, I would have needed to fill that up and then go on. So if this had been 2.6 times 0.4, we would have filled this whole one up and had a 1 in our hole. But we did not fill in a whole one. We covered in 9 rows, and there were 6 small ones left over. Go ahead and fill that in. And then we will move on. If you need more time, feel free to pause the video. See our answer here. Same thing of what we talked about. Without using models, explain why 2 tenths times 3 tenths is equal to 6 hundredths. Use place value in your explanation. Okay. Well, we have a 2 and a 3, which is 6. There are 2 decimal spots. So 2 tenths of 3 tenths. So 2 tenths of 30 is going to give you 2 out of each row, which is 6 individual blocks, which is 6 hundredths. Let's see what they told us here. And tenths times tenths equals hundredths. All right. Don't have to write that in. It was a talk about it. Let's do this one here before I have you some practice. Table shows some factors and their products. Study the table. Write a rule you can use to find the product of 2 decimals, both to the tenths place, without using models. And you can see again that we have the 3.3 times 0.7 is 0.21. 3 times 7 is 21. 0.4 times 2.4 is 96, or 0.96. 4 times 24 is 96. 0.5 times 1.1 is 0.55. 5 times 11 is 55. The rule is remove the decimal point, multiply as with whole numbers, then place the decimal point in the product by counting how many digits are to the right of your decimal point, and then moving your decimal point from the end over that many spots. In this case, 2 spots. All right, let's get you guys to practice. Let's start with number 6 and 7. We're going to do those two, and then we'll skip down to 10 and 11 after that. When doing 6 and 7, remember not to draw too dark so that you can kind of divide off lines and erase where you need to. I would recommend that you count 4 rows up and then 8 over and just figure out what your area is. I want you to go ahead and pause the video. I'll see how you did on the other side on 6 and 7. Let me pause the video now. Welcome back. Let's check out our answers. We went 4 over, or 4 up, and an 8 over. And that gave us 32 squares. 4 times 8 is 32. And there are 2 decimal places, 1, 2, because it's 32 hundredths. And you got that. 0.5 times 0.6. 5 times 6 is 30. There are 30 blocks colored in, so it's 0.30, even though it's not filling a whole row. All right, we're going to skip these two. And I want you to do first number 10. And we'll check your answer, and then we'll do number 11 separately. So go ahead and pause the video and do number 10 now. Welcome back. Let's see how you did. 0.54. You start seeing it's 3 up and 1 whole and 8 tenths over. So really 13 or 3 times 18, 18, 36, 54. There are 2 decimal places, 1, 2. So it ends up 0.54. And if you took these and colored them in, here's your first 3 rows. You take these ones, count them, color them in. And you'd see you have 5 whole rows and 4 little ones to get that 0.54. All right, let's go ahead and do number 11. Same thing. Go ahead and pause the video now. Welcome back. Let's see how you did. 0.2 times 1.4. So 2 up, 1 whole and 4 tenths over. 2 times 14 is 28. There's 1 and 2 decimal spots, so we come over 1 and 2. So it is 0.28. I took my 10, and there was 8 blocks on this one. And you can see they're right there. And we got 0.28. Let's pick one more story problem. Number 12 sounds good. Dana's house has a rectangular window on the door with a height of 1.5 feet and a width of 0.8 feet. What is the area of the window? Shade the decimal models to solve the problem. So this is where we start, and this is where you put your final answer. Go ahead and pause the video now. Welcome back. Let's see how you did. You can see that it's 1.5 going across and 8 tenths going up. Notice we didn't go 1.5 up because we didn't have anything above. And then I take that, I put these 8 tenths right here, and then I count, I have 5, 40 over here. So that's 2 rows and 2 rows. Our answer is 1.2, and we will label it with square feet. In rectangles, that is, it's square something, in this case feet, if you're not aware of that. All right, let's look at what the homework's going to be. And I recommend that you do it on this page and then put your answers in the Google form. Your other option is to make sure your name is on the top of this page and the top of this, and take a picture of it when you're done and either email it to mireland@sagchipschool.net or text it to me at 989-750-1640. On these ones, you're going to shade the decimal models. You can see on this one, because we're going to use multiple blocks, they gave you a spot to put it together. Same thing on 4 and 5 and 6, and then you're done. Hopefully this makes sense to you. If you're struggling with it, please reach out to me at mireland@psychchipschool.net or visit us during our office hours. The best way to get this material is during our in-class sessions. These videos are intended as either additional review or to help out a student who may have missed class for whatever reason. If you have any questions, I will look forward to hearing them. Otherwise, have a minal gizigad and minwa bamapi.